In this lesson, we will learn how to install a ball screw and adjust its height, uniformity, and symmetry. Next, we will explore this topic through the following sections. Through this lesson, I hope everyone will understand the working principle and assembly requirements of the ball screw nut transmission mechanism, master the fundamental steps for installation and adjustment, proficiently use tools such as vernier calipers and dial gauges for precise measurements and accurate adjustments of the ball screw's height, uniformity, and parallelism with the guide rail, ensuring assembly precision within the specified range. Develop safety awareness, team collaboration skills, and a careful and meticulous work attitude to prevent component damage and ensure assembly quality. Let's learn about the ball screw nut transmission mechanism. The ball screw nut transmission mechanism primarily converts rotational motion into linear motion while transmitting energy and force or adjusting the relative positions of components. It has the following advantages: high transmission accuracy, smooth operation, no noise, easy self-locking capability, and ability to transmit high power. The ball screw nut transmission mechanism is widely used in mechanical transmission systems, such as the longitudinal and transverse feed mechanisms of lathes and the bench vise used in machining work. During assembly, to improve the transmission and positioning accuracy of the ball screw, careful adjustment of the ball screw nut pairs fit precision is required. In this training task, we will install a ball screw and adjust its height, uniformity, and symmetry to help you to develop technical drawing interpretation skills. By analyzing assembly drawings, you will understand the relationships between components, as well as the motion principles and functions of the mechanism. Then, let's know about the preparation for adjustment and selection of tools and measuring instruments. Before installation and adjustment, all assembled components must be cleaned. Remove burrs, rust, machining chips, and oil stains from the parts. Rolling bearings should be lubricated with oil before installation as per regulations. According to the technical drawings, the height uniformity of the two bearing housings must be within 0.05 millimeters, while the parallelism between the ball screw and the guide rail must be within 0.04 millimeters. For this assembly and adjustment exercise, the following tools are required: copper rod, vernier caliper, dial gauge, magnetic gauge stand, and rubber hammer. Step 1. Install two angular contact bearings and deep groove ball bearings in their respective positions on the ball screw. During installation, place a copper rod against the inner race end face of the bearing, then strike the copper rod with a hammer. This transfers force through the copper rod, allowing the bearing to gradually fit onto the shaft. Avoid hammering one side only or applying excessive force, as this may misalign or crack the bearing. Apply uniform force and gradually install the bearing to ensure correct alignment. Place inner and outer bearing spacers between the two angular contact bearings. Precautions for bearing installation. 1. The marked face of the rolling bearing must be visible after installation. 2. Ensure the correct pairing configuration for matched bearings. 3. After the bearing is assembled onto the shaft and housing bore, there must be no misalignment, and the press-fit process should be uniform and vertical. After installing the bearings, proceed with installing the ball screw onto the bearing housings. Then, install the limit sleeve, round nut, and timing belt pulley onto the driving end of the ball screw to facilitate rotation. Once the ball screw is installed, adjust the height uniformity at both ends of the ball screw. Method for adjusting ball screw height uniformity. After installing the ball screw, measure the height uniformity at both ends, or measure the height uniformity of both bearing housings.
Use a dial indicator with a magnetic base to measure the upper generatrix of the lead screw, thereby determining the height difference between the center lines of the two bearing blocks. After the measurement,
based on the measurement results, insert an appropriately thick adjustment spacer beneath one of the bearing housings to ensure equal center heights for both housings. After adjusting ball screw height uniformity, we should move on parallelism adjustment between ball screw and guide rail. Use a dial gauge and magnetic gauge stand to measure the side reference line of the ball screw, ensuring parallel alignment with the guide rail. Tighten the bearing housing screws to secure the bearing housing in place. Important precaution. The ball screw and nut must not be separated during installation. If separated, the balls will escape, affecting assembly precision and leading to potential ball screw failure. Through this lesson, we have mastered the installation and adjustment process for the ball screw, including preparation work before installation, installation steps and techniques for adjusting height uniformity and parallelism. Additionally, we have developed an understanding of the ball screw nut transmission mechanism, its working principles, and assembly requirements. I hope everyone can apply this knowledge in real-world scenarios, continuously enhancing your technical proficiency. During operations, always follow safety protocols to ensure personal and equipment safety. Finally, please think about the following questions.